Here's my markers. Get this here. So let me just check. Okay, just seeing where the board cuts off, all right? Looks like that's about right. Okay, let's say we have two charges, and hopefully you can hear me. Actually, just if you can, give me a thumbs up if you can see everything, or is the audio okay, or is the audio cutting out? If the audio is cutting out, throw something in the chat, all right? I'll look at the chat. Okay, thank you for all the response. Okay. Okay, Priscilla's having trouble waiting for yours to come in. All right, so, okay. So Priscilla, today, maybe we're gonna have a little bit of trouble figuring that out, but remember I am live streaming this, so we'll deal with that. Maybe today you may end up wanting to just watch the live stream, and maybe you'll wanna stick around. So I don't know why your audio is cutting out. It sounds like it's working for most people. I actually remembered to plug in the hard connection this time. Earlier today, Jaden, I was on the Wi-Fi. So hopefully, Jaden, at the end, you could tell me if this is working, okay? If it's improved performance, and that will be something important for me to know. Okay, the letter we use is Q1. So this would be charge 1, all right? And maybe just to make this look less like a P, I'll do that. And then over here, let's say this is charge Q2. And right now, let's say we don't know. Maybe this is positive or negative and positive or negative. So Q1 could be positive or negative. All right. Now, let's assume that Q2 is -1 coulombs. Capital letter C is the unit of charge for Coulomb. So Coulomb is the letter C for Coulomb's law. All right. And let's just say Q1 equals +3 coulombs, okay? So we got two charges. Now, you know, the famous physicist Paula Abdul told us once that opposites attract. This joke is getting less and less good as the years go by. But anyways, yeah, Paula Abdul was a singer in the 80s who had a song called Opposites Attract. That's my reference. I'm old. I don't care. Anyways, so we know that 2, a negative charge, is going to attract charge 1, right? So I expect there's going to be a force, and this is where the words might help, force of 2 on 1, okay? And this is not a force. This, as it's written, I just wrote force magnitude. That would be the force, okay? All right, so, oh, okay. Oh, thanks, Priscilla, I appreciate it. And you can see my response time on the chat. I'm gonna look at the chat every once in a while. At any time, throw your questions in the chat. And you guys can talk to each other and say, oh, I think he means this, or you can just listen. Every once in a while, I will look at the chat and try and help you out, okay? So, all right, here we go. So we've got this force vector, and the idea is I want to understand these R vectors. So in order to see things a little better, I want to understand this. I want to get my book out so I can follow along. Just a sec here. Come on now. You'll probably hear me say, come on now, about 1 billion times. Every time something screws up on me, I'm going to say, come on now. All right. So, okay. So this is how I chose to do it, from 1 to 2. So this is R1 to 2. All right. And I believe that's how we're going to do this. So notice the force. Oh, I wrote this backwards. I wanted the force of 2 on 1. So this is the wrong R vector. By that, I mean, I wanted to get this force, and this one references R2 to 1. I wrote down the wrong one. And that's what I wanted to point out. You have to watch out for that. I wasn't reading closely enough what I was trying to do. This would not get me the right answer for a physics problem. So what I want to do is I want to get this way. If I want to analyze the force on 1, the force on 1 is going to depend on this radius from 2 to 1. So that's R2 to 1. Okay. Now, there's a hat vector this way. This is R2 to 1 hat. Now look at the difference. This one is very small. It has length 1. How did I get it? I took this giant distance and divided it by this magnitude. So let's say this is 7 units long. I took this vector and divided it by 7 to get the I hat and j hat components, okay? And when you do that, notice that allows you to punch into this calculation that we saw. Geez, I only have like 2 square feet. This is killing me, but it's better than no whiteboard, right? So in this case, we would say force of 2, and remember, you could watch the live stream later to catch up. So force of 2 on 1 would equal some constant. I'll tell you what that means in a minute. There's some constant, K, and then I need the 2 charges. I think this was Q2 and Q1, right? We had 2 charges, Q1. And then there's 2 ways to do it. We could do R2 to 1 and square that and multiply by this R hat. Now, notice when you plug in numbers here, when you plug in numbers, this one, I think that was a negative charge, right? So think about this. If this is negative, and I'm just going to draw this a little smaller over here. I think we had charge 2 was right here. Charge 1 was right over here. Okay, and let's just make up an R vector for this one. Let's say this is 4, negative 4 in the I hat meters in the I hat. And let's say this is negative 2 meters in the J hat. Okay, so R2 to 1 vector is negative 4 minus 2. This is I hat, whoops, I hat, J hat, meters. Okay, and so in this case, I could then figure out the magnitude. The magnitude, I'm just going to punch it in. You probably know this. It's just 4 squared plus 2 squared square root. So this x squared plus y squared square root gives you the distance, x squared plus y squared. So I'll just punch that in real quick. 4 squared. Okay, 4.472. By the way, you're going to see me do this all the time. Let's assume this has 3 sig figs. When you see me write this underline, I'm underlining what's called the doubtful figure. Let's worry about that later. Basically, let's just it's a habit. Okay, so now what I could do is this is the number that goes right there. And then I could take this. Geez, I need more space. Yeah, well, let's try it. R2 to 1 hat is equal to negative 4 I hat minus 2 J hat meters. All this divided by. Notice what drops out. And it's really hard to get like call and response here. So I'm going to just point it out. I hope you notice that the meters drop. Okay, so I'm going to ask a lot of rhetorical questions and say, oh, you know, yeah, all right. What do you think should happen? And I want you to think. If you want, you could chat with your neighbor, or you could chat with somebody else in the class that you know at any time and be like, I think it's this. And try to make it a little bit more interactive. So if you want, you could send messages to each other, or you could have a separate room on Discord or something that you got going, and you could be doing your chats over there if you don't want me to be involved. I don't care. Whatever makes it as interactive as possible for you, because online stinks. So we gotta try. Now, take a look. This thing right here is the hat vector. I could take that and shove it into there. And I believe we've got all the pieces except for this K. So I know how to get the distance, plug it in. I know how to get the hat vector, plug it in. I know the 2 charges from the previous whiteboard that I was working on. K is just some number. I remember it as 99, like the number 99, except it's 8.99 times 10 to the 9th, and then there's some units. Hopefully that's still on the screen. Sorry if it's not. Okay, so 8.9. Now you could look. We know the output needs to be newtons, right? I know I need to cancel out the charges. Well, the charges were coulombs, and there's 2 of them, so that's Coulomb squared. And I need these meters to cancel out, so I need meters squared on top. I think that's the units, but the idea is you could check the units on your own. And I think that's actually a question in a minute. So that's one way to do it. And that's kind of the classic way to do it. All right. And then let me see here. Okay. Oh, okay. Okay. So I'll scoot it back a bit. All right. That'll give me just a little bit, right? Every little bit counts. We'll try that. All right. So yeah, good. Thank you for the feedback, everybody. All right. So any questions about that one? Go ahead and throw them in the chat if you want. I'm also going to show you the other way of doing this that people end up liking more. Okay. Well, there's two other ways. Okay. So give me a sec. All right. So let me just get my... Okay, there we go. All right, so this gives, thank you. That almost doubled my size to work with, or at least 50%. So that's going to help a lot. So apologies if it's now too small for some of the rest of you. Nate Dogg, go for it. So Nate Dogg is going to send out the Discord study link that he's made up, I think. All right, so all right, check this out. Notice it doesn't matter what order you write the charges, right? They're just numbers. Whoops. So that's what we just did, right? We just took the R hat and did this. But look at this. Isn't R hat by definition? It's the vector over the magnitude. So rather than having to figure out the hat vector all the time, a cool trick is just to write the vector, but that it puts an extra magnitude in the basement. Well, that's exactly what this is, and that changes that to a cubed. And so from a practical standpoint, this is a lot easier. You get the R vector, you get the magnitude, you're done. If you're coding, this is a much easier way to code it. So we're going to do some coding in weeks 2 through 5. And then there's the rest of the labs are going to be a lot of videos, and there might be an option to do extra coding in one of the later weeks. So yeah. And thanks to Nate Dogg for putting that up there. Right on. All right. So we can talk more about that when I get to a logical breaking point. A couple of other things. I'm still on page 3. So let me see if there's anything that let me do. Sorry about that. Let me go to here. So right here's this equation. There's charge versus charge magnitude. This one is the charge. And this one is the charge magnitude. Obviously, if your charge is positive, the magnitude and the charge magnitude can be used interchangeably. It's whenever you have negative charges that you need to kind of pay attention in a problem. So in this case, I want to point out that the force vector uses charge. Okay, if you want to get the charge, let's say you just want the magnitude of the force, that's different. I need to erase. If you want to get the magnitude of a force, the force magnitude with no vector, you might think it's this. That is wrong. This is not correct. You need to stick on these absolute values. If you want to figure out the force mag, the magnitude, I need you to use charge magnitude. So just remember that. If you're using a force magnitude, use charge magnitude, okay? Because, right, if you get a negative charge in here, you'd get a negative magnitude. That doesn't make sense. So just be aware of that subtle little thing. Now, you might be saying, why would I actually do this? Why would I care? Well, some problems we can do without the R hat vector. Some problems we need it. I know at least one quiz question is a lot easier to use the R vector and the stuff I just talked about. Another quiz question, it's probably easier to use the magnitude. So you probably want to know both ways for the quiz that's coming next Monday. So let's say we had some problem like this, and you just have 1 and 2, you're like, well, I'll just get the magnitude. F equals K Q1 Q2 over R12 squared. And then I have to remember this is a magnitude. I'll put an absolute value on there. Put an absolute value on here. All right. And when I do that, I just be like, well, here's the force, and I know it's I hat. That's a lot faster than doing all that J hat, R hat vector crap. So every once in a while, it's faster to just get the magnitude and say, here's the magnitude, I hat. So I'm going to pause for a second and see if you guys have any questions. $21.3. And I think I used, I'm just going to check my solutions real quick to see what colors I used. And I'm going to try and match those, all right? Green, blue, and red. I apologize if anybody is red-green colorblind. I try to be observant of that and try to make sure there's at least a way you can see if you're red-green colorblind. If you are red-green colorblind, please send me something in the you can send me a private chat or just send me an email, okay? That will help me know, because if you're not, that gives us options. If no one in the class is red-green colorblind, I can talk about the colors better. So, but I'm not going to do that unless everybody's not red-green colorblind, all right? -2. And again, if you don't want to listen to me, use the solutions and go faster. Work as fast as you can. Q2. Okay, so there's our charges, 1, 2, and 3. We know this distance is 4 centimeters. And I hope you guys agree that this distance right here, you see it's a 3, 4, 5. So this we were told was 3 centimeters. So 3, 4, 5 right triangle, this one should be 5 centimeters. I figure that's okay. All right. And then I see. Oh, yeah. So that's one of the typos. Okay. Right on, right on. Okay. So just catching up on the chat. Okay, good, good, good. Right on, sweet. I appreciate you guys that had to deal with this in the spring, you know. That must have been hell. Haley raised a good question. All of the masses in there, I copied a problem from an old workbook. And so that's the kind of stuff that I cleaned up. Those should all be Q's. And so just to show you what I'm talking about, this is why you want to get the hard copy. It's just going to be better. 13, if you had me for 161, you're like, oh, I'd see this. This is just universal gravitation. So hopefully this is easy for some of you. If you didn't have me, hopefully you hit it pretty hard as well in Brian's class. Professor Youngblood. Anyways, taking a look at this one. This is kind of the, I think this is an important step. So I'm going to stop for just a second and maybe have you listen if you aren't. One of the things that you can do is, this class is a lot of math. And if you have a way to check your understanding with a concept, it's nice to be able to do that. So this is one of those things. Think about this. This red charge is opposite. So which way is it going to exert a force on number 3? I'll let you think. You don't have to respond, but hopefully you thought upwards, right? Opposites attract. This would cause an upwards force. So I'm going to call that F13 vector. These two are same sign, negative and negative. We expect this one should push away. Think, which force should be bigger? well, this one's a small charge, this one's a big charge. That makes me think this one should be bigger, but this one's a little bit closer. The distance is squared in the formula, so it turns out they're probably about the same. We don't expect one to be dramatically different, right? This one has twice as much charge, but more distance. So it might be something like this. As a result, we expect the net force by the parallelogram rule to maybe be somewhere over here. Right? So I would expect the net force to be right here. The net force is the red arrow plus the blue arrow, or you could say the blue arrow plus the red arrow, right? So the idea is we expect this to be over here. All right. And so we kind of have an idea for our answer. We expect something that's got a negative I hat, and it's not exactly clear for our drawing. I can't tell if it's going to be negative j hat or positive j hat, but the j hat part is probably a lot closer to 0 than the I hat part. That's what this picture is good for. All right, now go to work. Now you can stop listening. I'm going to get a sip of water. Haley, did I address your question? Okay. Okay, just responding to a chat there. And at any time, anybody that wants to can turn their cameras on, off. That stuff doesn't, I don't care about that. All I care about is you guys having an edge when you get to transfer, right? I want you to get good jobs someday. That's it. All right. And then this is kind of a big mess. Let's see what I can do with this on here. Oh. If I was doing this problem on a test day, I would not use that R hat crap for this one. Look at this. I know what this answer is. I know F13 magnitude is going to be K times 1 times 10 to the 3 coulombs, absolute valued. And then I'm running out of room. Let me scoot over. For the magnitude, I'm just going to absolute value those, right? So it would be K times 1 millicoulomb times 3 millicoulombs. And notice I took that absolute value, right? I absolute value to get rid of that minus. And then the distance is just 4 centimeters. And then I got to remember to square it because it's distance squared, all right? Okay. All right. And so then notice force 1/3 vector. All I'm going to do is just F 1/3 mag in the J hat, right? Because I have my picture. That to me is pretty darn easy. One of the things you got to watch out for when you punch this into your calculator, Milla, you got to put in 10 to the -3. Milla, 10 to the -3. Senna, 10 to the -2. And it's inside the squared, right? K was that 9E9, that 8.99 whatever number. Remember, K equals 8.99 times 10 to the 9th. I've run out of room, but you know what the units are, okay? All right, so that's how I get F1 on 3. Got it. Now I need to get this one, and then I add the two vectors. You cannot add the magnitudes together. You know this. This is the student thing that they get lazy, and they're like, oh, I got this magnitude, I got that magnitude, I'll just add them together. No, bad monkey. Remember, you must add the vectors. You cannot add vector magnitudes and expect to get the right answer. That's just no, no, no. All right, so F2 on 3. Well, to get F2 on 3, that's a little bit trickier. I know that R2 to 3, and this one sometimes gets people. R2 to 3, well, that's going to be negative 3 in the I hat minus 4 in the J hat centimeters. Because I go left, then down. Negative I hat, negative J hat. Centimeters, because centimeters. R2, 3, that's going to be just 5 centimeters. Man, these headphones are killing me after a long day here. I bet you guys too, so. All right, and so now that I know these things, I could use these and plug that in. For this one, it's actually easier to do it this way. I got K, I've got Q2 is -2 millicoulombs. I've got the green one, charge 3 is -3 millicoulombs. Now look carefully. I'm going to cube it so that I could just stick this R vector up here. Right? And so I hope you could see that all right. The idea then is that right here, I'm going to zoom in just a little. So you got it. Hopefully you could see that whole thing there. But the idea here is this is my 9E9. This is my millicoulomb. So I got to remember, I include the minus signs because it's a vector. This is the magnitude cubed because I use the R vector. So again, I'm doing vector over R cubed, whereas in the last one, I used R squared because it's a 1 over R squared law. This is a math trick to make less effort. I don't need to get the unit vector, all right? If you don't like the way I did this, you can, I guess, just not like it. All right, sorry, there's nothing else I could do. You gotta learn to do math, and that's it. So, all right. From there, I'm just